The year is sometime between the 1880s and the 1920s. A tribesman in Central Africa stalks his prey, a chimpanzee. He hurls his spear and bingo! The hunt is a success. But little does he know that his catch is carrying a disease known as SIV, or Simian Immunodeficiency Virus. In this man who came into contact with the infected blood of the chimp, the SIV virions acquired a random mutation, transforming into HIV, or a Human Immunodeficiency Virus. One instance of the butterfly effect would go on to radically alter the fate of humanity. In 1959, the first recorded case of the disease now known as HIV/AIDS was found in a man living in the Congo. The HIV virus was still undiscovered at this point, but preserved blood samples from the man were later confirmed to be HIV positive. From there it spread across the globe, having reached every corner of the Western world no later than 1970. In 1981, this mysterious new disease that had been causing a surge in rare cancers and opportunistic infections over the past decade had finally been recognized. Before the term AIDS was coined, the disease would bear several different names, including GRID, LAV, HTVL3, and my personal favorite, gay cancer. 2 years later, in 1983, the culprit behind the AIDS epidemic was discovered by this man, the virus known as HIV. As of 2020, it's estimated that nearly 40 million people in the world are currently living with HIV, a good amount of them unaware that they've been infected. It has also been surmised that nearly 80 million people have been infected since the worldwide pandemic was declared in the 80s. There is currently no cure, although advances in modern medicine have allowed the infected to live normal-length, healthy lives, and also reduce the amount of HIV in their systems to undetectable levels, rendering them incapable of transmitting the virus to other people. Although this has saved many millions of lives, it's hardly more than a band-aid solution. Firstly, the treatment is not only quite costly, setting you back upwards of $1,800 a month, but also must be taken in daily and precise doses. Second of all, many people in poorer or less developed nations can have trouble even finding adequate medical care and resources, much less being able to afford them. This is especially problematic as the majority of people with HIV are living in third world countries, specifically in Africa. No, nothing short of a cure will end the ongoing epidemic, and nothing short of a vaccine will eradicate HIV from this world entirely. Today we'll explore the possibilities and ramifications of both a cure and a vaccine for HIV, and discuss the obstacles and barriers that doctors are facing in the pursuit of these goals. Why does 40 years of research have yet to close the case? Before we can talk about potential strategies for an HIV cure, we need to understand how HIV actually works, and what causes it to be a lifelong, inescapable disease. Well, the answer lies in something known as latent HIV reservoirs. HIV is a virus, which means it is not a cell. It does not have the ability to self-replicate and is not technically considered alive. Viruses are parasitic in nature. In order to survive, they latch onto healthy living immune system cells, hijacking them and forcing them to replicate HIV virions, instead of the essential amino acids that the cells normally produce. Here's where the aforementioned latent HIV reservoirs come into play. For reasons still not entirely clear, some of the HIV-infected cells enter a so-called state of latency. During this latency, the infected cells lie dormant and do not produce new virus. HIV can hide away inside these dormant cells for decades, and at any time they can awaken and begin producing new virus. These reservoirs are one of the largest roadblocks standing in the way of a cure. Our current HIV medications prevent the HIV from multiplying, reducing the viral load of the body. Then, when all the remaining stragglers die out, the viral load reaches undetectable levels. But because the infected cells in the latent HIV reservoirs aren't producing any new copies of the virus, the medication has no effect on them. There's also the inconvenient fact that we don't even know how to target these reservoirs, because scientists still aren't entirely sure where in the body the cells that comprise them actually are. Scientists do believe a cure lies in our future. In fact, it may surprise you to learn that throughout recorded history, 2 individuals have already been effectively cured of HIV. In 2007, a man named Timothy Ray Brown received a bone marrow transplant as part of a treatment plan for his leukemia. His donor had a gene mutation known as CCR5, which effectively provides a natural resistance to HIV. The procedure was a success, and multiple high-sensitivity tests performed on the man's blood showed no traces of HIV in his system. The infection never returned. Brown was the only man to be cured of HIV until the year 2019, when another man living in the UK was cured of his HIV through a similar stem cell therapy. These were groundbreaking discoveries, an undeniably huge advance in the right direction, as they proved that curing HIV was at least theoretically possible. But what about stem cell therapy? Will it be the answer? Probably not. At least not for the foreseeable future. You see, the CCR5 mutation is very rare, making donors extremely hard to find. Not to mention that stem cell transplants and bone marrow transplants are risky operations, with a relatively high chance that the body of the patient will reject the new cells, becoming violently ill. And lastly, there will be obvious issues with ease of accessibility among the poor and among the citizens of the Third World. Although this is all very promising, it's far from an effective cure or a realistic treatment plan. There are currently 2 main approaches being taken by researchers at the moment in terms of curing HIV. First, there is what is known as a sterilizing cure, also known as the shock and kill strategy, which would eradicate the virus from the body entirely. This could be achieved either through an improved version of the stem cell therapy we've just discussed, or through experimental drugs known as latency reversing agents, which would be used to simultaneously activate all the latent HIV hiding inside immune cells, hence the shock part of the equation. Then, the reactivated virus can be targeted and killed by the immune system, or by anti-HIV drugs. The second approach to the cure is known as a functional cure, which would essentially put HIV into permanent remission, not eliminating the virus from the body entirely, but rather rendering it harmless. This might be done either through inhibiting latent HIV reservoirs from ever reactivating, or through gene editing that would render our cells impervious to attacks from HIV, or buff up our immune system to get better at fighting and recognizing HIV. Historically, vaccines have been the most effective way in all metrics of controlling or outright eradicating a disease altogether. Global vaccination campaigns are responsible for completely eradicating smallpox from the world by the year 1977, and all but eradicating polio, which remains endemic in only 2 countries as of 2021, with only 6 cases being reported in that same year. Both of these diseases are also viruses, by the way. But what are the challenges we face in developing an HIV vaccine as opposed to a cure? Well, as we've seen before, HIV is quite the outlier when it comes to diseases. Typically, vaccines mimic the immune response found in recovered patients of disease, who have built up enough antibodies to keep from catching the same pathogen again for a good long while, if not the rest of their lives. But the inconvenient reality is that there has never been a documented case of an HIV patient developing an immune response strong enough to clear the infection from the body. The second problem is that vaccines typically rely on inactivated or weakened pathogens as the active ingredient. But so far, inactivated HIV has proven ineffective at eliciting immune responses in clinical vaccine trials, and any form of live HIV pathogen is too risky to use, and has a pesky little habit of mutating quite frequently. The 2 primary paths researchers are taking in order to get around this are through developing improved vectors that efficiently deliver HIV genes to host cells. Therefore, they start producing HIV proteins, which elicits an immune response. The second way is through trying to harness the power of broadly neutralizing antibodies. These antibodies stop many kinds of HIV from entering healthy cells. While some people living with HIV make them naturally, it's always too little too late to overcome the virus. But as of 2022, the closest thing we have to an HIV vaccine is PrEP, a daily oral medication taken by people in groups at high risk for HIV, which can halt the disease from taking hold in the body and spreading. It also comes in the form of an injection taken every 2 months. When utilized and administered correctly, it is 99% effective. But at this point, I think it's obvious why it's far from a final solution. In order to completely eradicate HIV in the world, we need to take the same approach we did with smallpox, quite literally by getting almost everyone in the world vaccinated, through a giant globally funded and coordinated campaign by the World Health Organization. To wrap things up, let's compare an HIV eradication strategy to the smallpox one. In one regard, it would be easier to eradicate than smallpox because HIV spreads with a lot more difficulty than smallpox, and far more people on a global and annual scale were infected with smallpox and did get infected with smallpox at its prime, as compared with HIV today. In the other regard, HIV would be harder to eliminate than smallpox, because not only did smallpox symptoms take only 7 to 17 days to develop, and while AIDS symptoms could take 2 to 15 years to develop, but smallpox symptoms are way more visible and unmistakable than AIDS symptoms, which could be mistaken for a dozen other things. All things considered, in the matter of curing and eradicating HIV, the general outlook of the scientific community is one of cautious optimism. That'll do it for today. Thanks for watching. Until next time.